Let's check a bathroom GFCI. So first thing we're going to notice about this bathroom is you have your GFCI outlet right here. Green light's on, so it's operational in that sense, you'd think. Sink, and you have a mirror that has electrical power to it. So first things first, I got my Klein Tools tester here. It's a GFCI AFCI tester, and it'll tell you if there's any issues with it and any problems with the ground, etc. So right now it's not plugged in, it says open hot, because obviously there's no power. Plug that guy in here. Turn it on. Correct wiring. Now, there's power, it tells you. I could push this to test it. It did trip. So let's say if this was a GFCI outlet that was protected and connected to another outlet, I would not be able to reset this. And sometimes what inspectors do is they'll use their tester to trip an outlet to see if it's GFCI protected. And then they don't know where it's hooked up to reset it. And that's how people lose all the meat in their freezers, etc. If it's an outlet that doesn't have the buttons, but it's protected by another outlet in another bathroom, etc., because they'll string all the GFCI circuits together. So what you want to do is put a label on here that says GFCI protected outlet, so we know. So that way, when we find the outlet that's got the GFCI switch on it, I will hit the test button, and then I will go around the whole house and check them all again to make sure they're off. Okay, so now what I noticed when I turned this off, you see the green light's off? The lights on the mirror are off as well. So that means when I hit the reset button, that mirror is protected by that GFCI circuit. That at least tells me that it's connected to that circuit somewhere, that GFCI. Anything within 3 to 6 feet of a moisture source, all these outlets have to be GFCI protected. Therefore, that mirror, since it's an electric appliance and it's under GFCI protection. So that covers your how to test it with the Klein tester, this guy, right? Again, I'll post a link to all this stuff, the Amazon links. Another tool I carry on every inspection that I do electrical stuff with, like the electrical inspections, good old-fashioned multimeter. Fluke is really one of the best ones to get for the electrical testers, right? So what I'm going to do now is I'm going to turn this thing on, and we're going to check the voltage. So this thing's on. It's on voltage. I got my 2 test leads right here. I'm going to plug these 2 into the outlet, okay? So the small one is usually the hot. Now because this GFCI is tamper resistant, which you're going to have regular outlets in most homes nowadays that are tamper resistant as well, which means you can't shove these little leads in here, right? I've tried this and it's not letting me do it because these both need to be pushed in at the exact same time because these little plastic tabs are in there. So what I do is instead I plug my little tester in that you guys saw earlier. And where you want to touch these leads is you want to put the red on the hot, which is in the small port, and you put the black onto the ground, which is this guy. Now you can see I'm touching the hot, the little hot bus. I got the ground in here. You can put it in the other one, or if it might be a split circuit, you're better off touching it to the ground bar on this one. So it shows me 125 volts AC. Why does that matter? When you have voltage fluctuations, sometimes if it's too low, it can damage your appliances. Or if it's too high of a voltage, it's a fire hazard, right? So this is also a good way to detect sometimes if something's cross-wired, improper connections, or if it's just an old corroded wire and it's not transporting voltage properly, which means there's a hot point in there somewhere that's probably going to light on fire at some point. If you don't have enough voltage, it could also mean that it's too far of a run, right? It's too far away from the panel, which means you're not going to get too much of a voltage drop over that wire. Let's put the thermal camera on it. Something you notice? Yeah, runs pretty warm, eh? For a GFCI outlet, that's normal. Okay, so that's not a cause for alarm. Let's say you get one of these thermal cameras and you go around and you check your GFCIs and all your electrical outlets, and the GFCI is a little warmer, perfectly normal, nothing out of the ordinary. Just as I said before, watch the temperature. If it's really hot, that's a problem. Now while we're here, yeah, that works.